Kepler 22b, the alien world that shouldn't exist in the vast expanse of space. Our galaxy, the Milky Way, is home to hundreds of billions of stars, each potentially hosting planets. For centuries, humans could only dream about worlds beyond our own. Then, in the early 21st century, the Kepler Space Telescope changed everything, revealing a universe teeming with planets, some familiar, many utterly alien. One of the most astonishing discoveries of Kepler's mission came in 2011, a planet named Kepler 22b, orbiting a sun-like star about 620 light-years away in the constellation of Cygnus. This exoplanet immediately captured the attention of astronomers, the imagination of the public. The discovery, the Kepler Space Telescope, launched in 2009, was designed to find exoplanets by the transit method. This technique detects the tiny dip in a star's brightness when a planet passes or transits in front of it. Each slight dimming tells scientists the planet's size, orbit, and sometimes hints about its composition. Kepler 2b stood out because of its location within the habitable zone, the region around a star where liquid water could exist on a planet's surface. This made it one of the first potentially Earth-like planets discovered at the time. However, Kepler 22b immediately defied expectations. A world that shouldn't exist? Why shouldn't Kepler 22b exist? Scientists were puzzled for several reasons. Size and composition mystery. Kepler 22b is roughly 2.4 times the radius of Earth, placing it in the category of super-Earths. But this raised a problem. Planets of this size should either be rocky and inhospitable, like a massive version of Earth, or gas-rich, like a mini-Neptune. Which was it? Its exact composition remained a mystery for years, and the uncertainty made it an unusual, almost forbidden world by standard planetary formation models. Orbital peculiarity: Kepler 22b orbits its star every 289 days, remarkably similar to Earth's year. Yet its star is slightly smaller and cooler than our Sun, meaning the planet receives only about 1/3 more sunlight than Earth. Calculations suggested that if Kepler 22b were rocky, it could potentially support oceans, but a thick atmosphere could also create extreme greenhouse conditions. Formation theories challenged. Models of planet formation predicted that planets of Kepler 22b's size and location were extremely rare. Small rocky planets should form close to their star, while gas giants form farther out. A large super-Earth in the habitable zone didn't fit neatly into either scenario, making Kepler 20 to be a tantalizing anomaly. About the alien possibilities. Kepler 22b remains a puzzle because we don't yet know its exact surface conditions. Scientists have speculated wildly. Ocean world hypothesis. Some models suggest it could be entirely covered in water, forming a global ocean hundreds of kilometers deep. This would make it unlike anything in our solar system. Thick atmosphere scenario. Alternatively, it could be a mini-Neptune with a thick hydrogen-helium atmosphere, rendering its surface uninhabitable despite its location in the habitable zone. Exotic life potential. If conditions are right, life as we know it could exist, but perhaps not on land. Any life would have to adapt to extreme pressures, dense atmospheres, or oceans with unknown chemistry. Scientific significance: Kepler 22b's discovery was more than just a fascinating data point. It changed the way scientists search for exoplanets, expanded the habitable zone concept. Kepler 22b showed that potentially habitable planets could be much larger than Earth. Challenged planet formation models. The existence of such a planet forced scientists to rethink how planets form and migrate in their systems. Inspired next-generation telescopes. Its discovery fueled interest in missions like the James Webb Space Telescope, JWST, and TESS, which aim to characterize exoplanet atmospheres and compositions. Current and future research. Even a decade after its discovery, Kepler 22b remains enigmatic. Modern telescopes aim to detect its atmosphere and climate, searching for water vapor, clouds, and potential biosignatures. Each new observation brings us closer to answering the ultimate question: could life exist there? Despite being so far away, Kepler 22b reminds us that the universe is stranger and more exciting than we ever imagined. It is a world that defies conventional science, yet continues to inspire curiosity and wonder. Conclusion: Kepler 2b is a cosmic paradox, a planet that should not exist according to our models, yet does. It challenges astronomers to rethink the rules of planetary formation and fuels our imagination about alien worlds. Perhaps in the future, with more advanced telescopes and missions, we might finally uncover the true nature of this mysterious super-Earth. Until then, it remains a tantalizing symbol of the universe's limitless possibilities, distant alien world that both puzzles